We have a simple problem that came in JEE Advanced 2017. We are given a function 1 minus x times 1 plus absolute value of 1 minus x by absolute value of 1 minus x cos of 1 by 1 minus x. We need to understand how this behaves at 1 when x approaches 1 from the either side, right? From either side of 1, whether the limit exists, it doesn't exist, whatever. Okay, so obviously, um, when x is approaching 1, right, this is 1, and x can approach from this side or from this side. When x is lesser than 1, 1 minus x is positive. When x is greater than 1, 1 minus x is negative, right? When x is approaching from the left, x is lesser than 1, 1 minus x is positive. And approaching from the right, 1 minus x is negative. Okay, so then let's try to understand how what happens when x approaches 1 minus or 1 plus. Okay, now when x approaches 1 minus, okay, 1 minus, that is from the left. This is 1, this is from the left. So 1 minus x should be greater than 0. This is positive. Right, so absolute value of 1 minus x will be 1 minus x, and absolute value of 1 minus x will be 1 minus x. So this becomes 1 minus x times 1 plus 1 minus x, that is 2 minus x. Right, 1 plus 1 minus x times 2 minus x. This is equal to 1 minus 2x plus x square, which is nothing but x minus 1 whole square. We have x minus 1 whole square by 1 minus x, which is nothing but minus of x minus 1. This should be equal to this, and this will get cancelled, minus of x minus 1, right, which is nothing but 1 minus x, right. So this entire part will turn to 1 minus x and cos of 1 by 1 minus x. Now we have x tending to 1, right, from the left. That means x is coming closer to 1. So 1 minus x is 0, and the cos of 1 by 1 minus x. This part, whatever it is, it will always lie between minus 1 and 1, because this is cos, right. Right, whatever cos, it will always lie between minus 1 and 1, and 0 into whatever is this is 0. So the limit when x comes from x tends to 1 minus is actually equal to 0. What happens when x is approaching from the right? When x is approaching from the right, x is greater than 1. So 1 minus x is negative. So absolute value of 1 minus x will be minus of 1 minus x. Right, let us do that. So this becomes 1 minus x plus 1. Again, this becomes minus of 1 minus x. That is 1 minus 1 plus x. And absolute value of 1 minus x is minus of 1 minus x, which is nothing but x minus 1. Now, this and this will get cancelled. We have 1 minus x square by x minus 1, which is nothing but 1 minus x into 1 plus x by minus of 1 minus x. This and this will get cancelled. So we have minus of 1 plus x, right, minus of 1 plus x cos of 1 by 1 minus x, right. Now if we take minus of 1 plus x, this becomes minus 2, and cos is ranging between, again, minus 1. Cos is always ranging between minus 1 to 1, but we don't know what exactly is this. So we cannot clearly say whether it is minus 1 to minus 2, which is plus 2, or minus 2, or something in between. We cannot clearly say, because cos can be anything. In the earlier case, we could say, because whatever cos is varying, whatever cos is happening, the one before that, whatever happens to this, but this one is actually approaching 0. So that's why you can say it is 0. But here, this one is actually minus 2. So whatever happens inside, so we cannot clearly say. We need to be able to exactly say what exactly is this. If cos of 1 by 1 minus x is some 1 or 0.1 whatsoever, then we can say what exactly happens to this multiplication. Now here we cannot say, it can be anything, right? It fluctuates a lot. As x becomes closer and closer to 1, 1 minus x will become closer and closer to 0, and cos of 1 by very small number, this small number will actually fluctuate a lot. Right, so we cannot clearly say. So what does that mean? Limit x tends to 1 plus. Does it exist? Limit x tends to 1 plus. It does not exist. it does not exist. Limit x tends to 1 plus, this is not 0, it does not exist, this is true. And limit x tends to 1 minus, it does not exist is false, it exists. And what exactly is this? Limit x tends to 1 minus, we have figured out it is 0, right? So this is also true, right guys? Very, very simple problem. We just need to make minor algebraic manipulations and then verify, right guys?